Okay, so today's session would be on a language called Clojure, which runs on JVM. Which Clojure is a Lisp dialect. Okay, how many of us heard of it before? Heard of Lisp? Okay, done Lisp, calculator in Lisp. Okay, okay. So right now this is Visual Code. I have started the REPL, which is hosted on this port 50635. Okay, and it is connected to my IDE. Okay, to this server, I'm gonna send the instructions, which is the code. Okay, and in today's session, we will be having different features. We will see the different features, but only at the high level. What are the capabilities of Clojure, the core concept, the core constructs, the data structure, various ways and the features of functions, Java interop, macros, and building abstractions, and some concurrent and parallel features. Okay, to achieve the concurrency and parallelism. Okay, so as I said, Clojure is the Lisp and which follows the certain construct. So all the program, the whole of your Clojure program is actually treated as a data, the list. Okay. In language like, for example, Java, this is not the case. It has a syntax and all, but in Clojure, the whole program is treated as list itself. Okay. And it follows something called as S expression. In S expression, the first parameter which you have is operation or a function, and rest of them are the arguments. Argument could be a function, arguments could be a data. Okay, so this is the very simple syntax of Clojure or the Lisp per se. Okay, but there are some special forms which are not inbuilt. So most of the Clojure code, the base code is built into the Clojure language itself, like standard library and functions and so many things. But there are something which are natively supported special forms, and those are if, let, do, quote, loop, recur, throw, and try. Okay. Other than this, all of the things like when and all conditions and switch like condition, as we're going to see, all of these things are built into the Clojure by using the Clojure language itself. Okay, so the first thing is if I like to know what is the Clojure version, so I can just select it, send it to the nREPL, and it will say 1.9. That's the version I'm running. If you want to see or get the information of some inbuilt functions or any other thing, you say doc. It will retrieve the doc. So where doc here is a function, and the other the alien symbol to you or the function to you or the macro to you is acting as an argument. So what is the map? So map is defined in clojure.code. This is the package name, namespace name. Okay, so just like I have here, namespace clj.core. Okay, and the name of the file is also core.clj. So the extension you use for Clojure file is .clj. Like for example, .java, .js. Okay. What is plus? Plus is also a function. Okay, Clojure allows some operators or any parameters, special symbols to be act as a function, treat as a function, and define them. So this is like return the sum of the nums. Okay, println is your standard sys.out.println. Okay, just Okay, so let's move on to the basic types. So characters, like for example in Java, is in single quotes, right? In Clojure, it is slash the character name. So it will print the same. A string, same as Java, quotes. There is long, there is a double, and Clojure has a special type where it does not evaluate like 22 by 7. It won't evaluate 23.14. It will keep the both the information like numerator and denominator. Okay, so there are fractions. Uh, the booleans are simply true and false. Okay, there are something called as global variables or global dynamic variables. Like for example, I like to know the namespace name. Okay, oh sorry. So this is the namespace clj.core. If I would run this println statement in any other file with a different namespace, it will give that. So it's like a current. What is the current namespace I'm in? Okay, this is byte. A single byte is represented as this, which is the hex 100. Clojure has something called as symbols and keywords. Okay, symbols are something which is so your whole program in Clojure is a composition of list. Okay, so if you do not want something not to evaluate, you prefix it by a single this thing like this. So it becomes a symbol. Keyword is a symbol which points to itself, or you can say it as like a constant string. So instead of using string, you use the keywords. Keywords are used as a keys in hash maps instead of just using the strings. The advantage is just that it's a different than string. It's immutable. Of course, string is also immutable, but it is it doesn't have any other functions. It just like the very unique itself keywords. It doesn't have any other functions. This is just the pure symbol which points to itself. You can create a keyword out of a string or many string. Keyword could be any. So keyword, if you say 123, it won't work. It only works if you pass the argument as a string. Like you can convert only a string or the list of strings to create a keyword out of it. Okay, let's say if you want to guess the type of certain variables or the values. Okay, so that's a character, Java lang character. The type of this thing is Java lang string. A simple is long, is not integer. Short, you can convert it if you want to convert it into, so these are like conversion functions. If you do not want a very precise like wide range of values, you can convert them into a integer or the short. By default, it will show double for this value. If the value gets too big, it automatically converts into big int, which internally points to big integer Java. It's double, and the double. Double can take it. Okay, what is the type of map? It doesn't tell you that it's a function. It shows you the namespace it is in and the name of it. Okay, so is the case with print. Boolean. Okay, so this is the symbol. So I have not defined anything here, right, in this context. But I'm still saying that what is the type of this? So it's not evaluating it. So whatever comes after this single code, it is not evaluated. It is just treated as some data, some string, not even data, some string. Okay, you can evaluate it by actually having different functions, but that depends upon what kind of data you have. Type of this is keyword. Okay, so these are basic types. Any question? Nope. So let's say add. If for one argument, it's suppose that the other thing is 0. 3. It's a so the add function here, the plus function here is accepts not only one parameter but various other parameters. Okay, so in Java you would have written 1 plus 2 plus whatever 2 plus 3 plus 4. Here the operation is mentioned only one time. The arguments are then repeated. Okay, the similar is the case with subtract. But here it assumes that if you only pass only one argument, the other argument is 0. Okay. What would be the result of this? 4. Yes. 10 minus 5 is 5. 5 minus 1 is 4. Okay, so it takes this 2, then this one, and then this one, and so on. Multiply, the same story. Sorry. Yeah. Division. Now if I say division, it's 1 of y1 because 1 by 2, it returns a fraction. Okay, 1 by 2 by 3, the whole thing. Okay, but sometimes you don't want fraction, you need near precise values. So what you do is look at the first argument after you mention the function, the operation you are trying to do, and say dot. So it will give you near precise value depending upon what you're trying to do. And if you want manual precise value to be cast down to a float or a double, then this is the way. Okay. Of course, there is a modulus operator. Yeah. So say suppose. Okay. Any question until here? It's a simple thing. What we are seeing is operation function and the argument. As simple as that. So these are all. Now the next step is to define a variable. How do you define a variable? Okay, so right now I'm defining a variable and also it is dynamic. Okay, so suppose if it is not, say, dynamic, mm, and if I define it, okay, so I define x, okay, I define y, and then I do the addition of them, okay. Now, Clojure has something called as binding. So per thread, you can overwrite the value of the vars. These are vars, okay. Uh, this x and y, unlike Java, does not point. It's not a reference handle to a particular memory location, okay. It's so. If you take an example of C or C++, we have pointers to a particular memory pointer. Okay, then Java got rid of it, introduces the handle. So there are no more pointers. Okay, so you have a variable, internally it points, but it doesn't give you the actual memory location. It is abstracted away from the JVM at the JVM runtime. Clojure has one more abstraction on top of it. Okay, so X is not actual memory location, not a handle. It's the another runtime var handle at the Clojure runtime. Okay, and you may choose to bind its value to a different value than originally defined by having this binding feature on a thread level. So suppose you have defined X and Y. For different threads, you want them to see a different value of these variables. Okay, so why? Because Clojure implement STM, something called as software transactional memory. So it has to have one more layer above it. So even if you don't understand right now, it's okay, but understand the usability of it. That would be much further on. So what you can do is you can define them back as a dynamic variable, and now you can bind to a different value. Okay, it sounds like you are mutated, but it's like restricting down your bindings for a particular variable on a thread basis. Okay, these are constant. You define it, you print it. Sorry. There is also a late. So if you have, so as your program grows, right, you will have some scoped variables, right? And if you want that scope variable to be this, so what we have seen, binding is at thread level. But if you want at function level or code level, you can do it with let. So in this, so it introduces this let form. It is not a function. Let is a special form. I'm saying that A gets a value of 10, B gets a value of 20, and then please return the subtraction of it. So it's like a local scope variables. If is also a special form, but it acts as a ternary operator. So this condition, if this condition returns true or nil, sorry, false or nil, then switch back to this. But if it is true, then return one. So let's say, so it will return one if it's odd, right? If it's a nil, then the else part is returned. The whole value is returned. Okay, what about the empty? True, yeah. So falsy values are false and nil. Rest all of them are truthy values. Will evaluate to true. Okay. Uh, Clojure also has some, high level forms for switch. One of them is the very basic one is condition. Again, we are defining a block, defining a grade variable which holds the value 75, and I'm checking if condition. Okay, so this if so condition accepts what? The Boolean value and the value to be returned. The Boolean value and value to be returned. Sorry, the function, the block which returns the, sorry, not the Boolean value, the block which returns the Boolean value. They are not evaluated. So when you actually execute it, they are evaluated. There is no break condition, nothing. Yes, it starts from the very upper one. Wherever it finds the match, it returns it. End of the story. And this is like the else. So it is analogous to the default in switch, Java switch. Yes. Okay, and so this condition, so all of the forms like, so because Clojure does not differentiate much between the code and data, you can implement your own language feature in the language. You don't have to wait for new version of Clojure to be released. You can implement your own feature. So this is one of the feature. You implemented the switch condition by yourself, right? So if you go to this cond, so it's a macro. I'll cover the macro little later, but it's something like, it's a very simple form. You could have it implemented by your own. Okay. There is another like condition predicate cond p. What it does is it takes this function, the first, uh, take the case statement value as a first argument, and these are the second argument. Okay, so if I execute this, so cond p, is the value equal to 1, 2, or 3? If it is nothing else, then return this. Okay, slightly more complex example would be this. This is the function. Okay, maybe I can come to that later. So this is anonymous function. Okay, let's conduct it. This is the anonymous function. Okay, so it starts with this hash. Okay, this is the first argument. This is the second argument. First, it's saying that first argument is a function, so call that, and second argument is the argument to that function. So string of foo, keyword of foo, symbol of foo, or fn of foo. Okay, so it's saying that it's not a string, it's, so let's print it. Are you able to understand what's happening here? Okay, is it visible? So cond p is a function which takes a function. So since everything is a function, you can pass always a function and return a function in Clojure. Okay, so what I wanted to do is, this condition was a simple switch condition. It just checks the simple value over it. But what if I want something very dynamic? Okay, so what I would do is I would pass this the case statements which we have written here. Here it was just returning a Boolean value, a blocks which returns a Boolean value. Okay, here these are actual functions. Okay, so what it end up doing is string of foo. So let me show you. So what it string of foo. If it is there, it's okay. If it is not there, then go to next one. Like that. So whichever returns the Boolean value again. So I just made that block, this one, dynamic. Okay. How it is doing it, not a problem, but what are you achieving it? Just focus on that. Are you able to understand what you are able to achieve? Switch. But it's a dynamic switch. I'll come to this example little later because it's very high level. Okay, so let's look at for loop. What is for loop? Again, a special form. So range, so this one, give me a range of 5. So what is range of 5 does? It gives you list from 0 to 4. Internally, it gives a sequence which is a lazy. But when I'm evaluating in the REPL, it prints out the whole value. It realizes the whole value. But actually, it is a sequence. Whenever you access it, just like a iterator, Java streams and all. Whenever you access it, whenever you say next, give me a next value, only it is realized then. So what for does is iterate simple. It simply iterate with that value and return it also. So in C, C++ or normal imperative languages, for loop doesn't return anything, doesn't have to. Okay, so this is like a for each version of Java which also returns something. Okay, so what is gonna return? The same thing. Okay, so this is for comprehension, which is working on more than one ranges. So internally, it says that whichever I'm getting here, it's a sequence value. It will do a cross product of it. Okay, so 0 to 4, 0 to 4, 5 times with all these things, and it will do it's what? Are you able to understand this? So first, why first values are 0, 0, 0? First 5 values? Because A was 0 for all the values of B. Then A was 1 for all the values of B. As simple as that. Okay, so for can have, if you want inside the for loop, if you want to hold or define some variable, temporary variables, okay, do a certain computation and also have some condition to evaluate it. So this is like let y be this, and when it is even, then return this. So 0 to 99 into what? Into 3, then only choose even values. So this is like map, this is map, and this is filter. Okay. But do remember that by default, Clojure, all the data structure, as we're going to see, are immutable, and they inherit from something called a sequence data type. So sequence is not realized value; it's a lazy value. Okay. Okay, you can also have while, which is yeah, not equal to is a function. So Clojure libraries has very many functions, which are kind of so it follows the philosophy of a functional programming. Like instead of having very many data structures and few functions to operate on them, have only three data structures, like mainly list, vectors, and hash maps. Okay, and have many functions which are commonly shared. Of course, the behaviors would be different. So Clojure has three or maybe four, like list, vectors, hash maps, and sets. Sets internally are nothing but a hash maps without values. Okay, recursion loop. So in Java, if you recur over something, okay, it which has a very high value, the recursion goes on, like for example 1,000 or 10,000, it might result into stack overflow. But Clojure has something called as loop, which is again loop, and recurred is again a special forms which help you achieve the um, tail call optimization. So your recursion thing is evaluated into iteration. 55. So what is it doing here quickly? Loop define A with 0, B with 1, and also it act as a function, anonymous function. Okay, if counter is 0, then return the value of A. Otherwise, we have seen if, right? If condition, this is the true. If it is true, then return this. Otherwise, recur. So this is the function call to this loop with different values. First, it was started with three values, which is defined 0, 1, and 10 for A, B, and counter respectively. Now it is dynamically doing it using recur. So loop, so you cannot write recur without loop. They always comes in combination. So everything is a function and they return some value which act as an argument to another function. But what if some of the basic things are, statement 1, statement 2, statement 3, those have side effects, right? So it doesn't return anything, or even if they return, I don't care. So how do you do that? So for that, you have a do block or a do monad from Haskell. In this, you write a normal statement like Java, like define x as 9, assign the value 90 to x, 160 to y, add them, print the addition of it, and return the set. So this is a set syntax. I'll go on that later. Okay. So do blocks execute the statements one by one, which results into the side effects, and also returns the value value of last expression. Any question?
So def is a keyword.
Def is a keyword.
Python, we define a function with def.
Yeah, so here you define a variable, or should I say global variable? Yeah.
That is what local variable.
Yeah. Hmm. But this def is like context will be inside the do block only. It's not accessible outside the thing. So def So internally, let does the def only, but it has very many other things, which we'll see while we see the destructuring.
Is it sorting somehow? Set?
Is
Is that set a sorted set?
which set?
Hash is a set, right?
Yes, this is the syntax for set.
So y's value at that instance is 160 or something else? 171, line 171. Y's value is 160 or something else?
90 or 160, 90 and 160, right?
So y we defined with 160, right?
Mm-hmm.
And x is 90.
Yes.
So we printed in the reverse order y and x. So it should be 160 90 or 90 160.
Set doesn't have a order, right? It's just a two string of it. It's not an ordered set.
So it's not sorting according to the value.
It's not ordered set. It's not a set.
Run it again.
Yeah, so it might change. I mean, Clojure has ordered set, but this is not one. It will change. Right now, there are only two variables, but if you have multiple variables,
Can we print x and then y?
we can do that when we see the data structure. Any other problem, any other issue do you have, or question do you have? So do times is again a macro, simple macro. Okay, so suppose Java doesn't have a, you wanted to create do times, you can't create. But in Clojure, you can create with macro. What it does, it takes the index, okay, and it execute this block, which is registered to it, these many times. As simple as that. Okay, so it has printed from 0 to, ignore the nil value because I'm passing it to the REPL, that is why it is coming. Okay, there is something called as quote, syntax quote and unquote. So these are different. As I said, let's look at a quote, normal quote. Okay, so whichever comes after this quote, I said act as a symbol. It is not evaluated, right? So it turns everything into, so it did not evaluate. It just, treated as a string, not even a data. Okay. But if you do backticks, okay, it will evaluate. Now, watch the difference between these two. A single quote, the whole string as this thing, and backticks. What backticks did? It identified the functions in this context. So plus points to closure.code. If I would have written X, it would have written the same value of it, but it did not evaluate. It only evaluated the so-called the definition or the reference of the function, but did not evaluate the block itself. Okay. And this is called as quote. Quote is this comments. Okay, so either you write like this, or you write, say suppose example, you write like this, or you write like this. It's the same. There is also, okay, so let operation, this is the symbol, because we know that So for now, just don't focus on it. So suppose if I evaluate it, what is going to print? Clojure, some operation. Okay. So it did not take the value of the plus, but if I want it to take the value, I would use tilde. So it's like plus. So what we achieved earlier was by directly having it plus. But what if the plus is the value of some variable? The plus function itself is the value of the variable operation. Okay. And there is another one which kind of, this is like a spread operator in JavaScript, ES6. So I have defined the x value as a 1, 5, 10, and I'm spreading over the list 1, 5, 10, and the last member is 15. Okay. Try catch finally has a fairly straightforward syntax. There is a try, there is a whole block. Yeah. Inside try, the first thing is your actual block, multiple blocks, then catch, and then finally. So what it's gonna print? What is gonna print?
Final exception and caught exception.
Yes. Oops. Sorry. Final exception and caught exception. So finally comes first, and then the catch. Okay. Any questions?
That's how you get why did finally that's oxymoronic.
Oh, what?
Oxymoronic.
Oxymoronic. Acha. Acha. Ha. Okay. So let's see at the data structure, basic data structure, list vectors. So if you so the way you should define list is having a symbol, because because the basic very is list. The whole program is into the list. To realize the list, you have to treat it as a symbol. Okay, 1, 2, 3 by having it. If you try to define this, it will take exception, because what it's trying to do is it is trying to say that 1 is a function and the 2 and 3 are the arguments to it. Okay, so what is the type of this? Persistent list. So internally it is an immutable persistent data structure. Persistent not as in the sense that it is being persisted to disk, but as in the hierarchy of it. Okay, so whenever you add something or remove something, it is done by structural sharing. I won't get into that, but from usability point of view, just remember that it is immutable. And by structural sharing, it tries to minimize the so whenever you convert one data structure into another data structure, it tries to minimize the newly data structure by minimizing the memory space acquired by structural sharing. So suppose you already have some data structure with some values, and the output data structure also have some structures which it can borrow from the already structures in the memory. It will point to that. That's like space efficiency. Okay, so what is the type of this thing? Persistent vector. So round brackets are list with the prefix this thing, and the vectors are these. If you can also print it. There is another way of doing list like 12, 34, and 65. List is also a function. Okay, so there are some higher order function, like I like to know what is the first of this. This is a 7. What is the second of this? So there are many functions for vectors, list. What is the last of it? Same is the same is for vectors like rest. Able to understand first, last, and the whole rest. Linked list. We have functions. Okay, so it can be passed to this thing like map identity. So what is identity? Whatever receive as an argument, return that value. That is called as identity function. Odd is what? You're just passing the reference of odd. So across this vector, what are the odd values? So it will return true, false, true.
Um, Identity is a function, right?
Hmm.
Odd is also a function.
Yes.
So why the extra question mark?
Yes. So in Clojure, the function which returns a Boolean value ends with question mark. That's the convention you follow because it's a predicate. Otherwise, because everything is a dynamic language, everything depends upon symbol. So how do you differentiate between these things? That is why they do not have a string, they have a keywords. They do not have a simple odd function. So you have to have much specificity when you define functions or some kind of best practices to define as to it's a different simple transform function or a predicate function. So all the predicate functions are ends with question mark.
So it's a guideline or a
Guideline. It's not a mandate. So how do you define a simple function? Like this thing. Define the add and then this anonymous thing fn, or simply like this defen. So defen is a again what? A macro. Okay, I won't go into that. It's like okay. So what is it? Defen, name of the function, arguments to it, a and b, and what does it returns. So it's the same. So if I define as reduce, add. Reduce is very similar reduce, maintain the accumulator also while you are iterating over the collection and then return the value of the accumulator. So 1 plus 2 plus 3 plus 4 plus 5. Reduce, add. Okay, from 0 to 4 is 10. Okay, so same would work for this. If I define this and evaluate the same thing again. Okay, so we already have seen it, but the lambda function is like, so there are two ways, like this is anonymous function which doesn't have anything, but if you, the more shorter form would be this lambda function. Okay, so I define a variable which is nothing but a range, yeah. Then what? I reduce over it. So what it is doing? Reduce. So it's add. Okay, just I have defined it here is the add function. So it start from this percentage first for percentage second is the argument order.
Hash curly is set. Hash round is function.
Hash curly is set, hash, yes. So, so if you have only one, so here you have two arguments, but if you have only one argument, you may not bother defining its order. You can just say simply percentage. So what it does, 1 to 100, yeah, not even, is odd. So this is equivalent. This is equivalent to taking a function. Okay, let me kind of. So this is equivalent to defining a function. Say something like odd or my odd, because there is already an odd, which takes what, num, and does what? It first finds out if it is a even, okay, and negates it, simply negates. So it is equivalent to that. That's a shorter version, short. That is why you reduce at least 3 to 4 times of code compared to Java. Okay, sorry, what am I doing? Just remember, all of I'm showing is function which accepts a function or the data. And data are the data structures. List, vector, hash maps, and so let's look at maps. Keyword A, or you can also define keyword instead of keyword A and keyword B, you can also define string, but the normal practice is like to define keywords because they are specially that. They have unique, like they're unique itself, they don't do anything, they have very short purpose. So print, so what is gonna print? AB, shorthand for this. Okay, so this is equivalent to what? New Java util hash map, store it in the variable dot put AB dot put B2. Okay, and this is what, okay, so the one so keywords are the symbols which points to themselves, but they have one more thing, they can act as a function in Clojure. Okay, so here it is acting as a function. Hyphen A, give me the hyphen A in the maps. Okay, or hyphen B, get me the hyphen B in the value of this key. So what if you want to go, so one level hash map is okay, but what if it is a nested hash map? This is nothing but a JavaScript JSON, but this notation is called as EDN. It has little other properties which I won't discuss today, but you can find it out. So A has a value which is actually an object, which is a hash map, which has a key C1, and come out of it at the 0 level. That's 1, 0 and 1, or 1 or 2 level. So 2 level. Okay. So I'm getting in with mentioning this. So this is vector. So I can go until the depth, any depth. Okay. Are you able to relate it with Lambda functions? These are all present in Lambda.js, for JSON. So what are the keys? Give me all the keys of this maps. Give me all the values of this maps. All of these are functions. Functions. So coming from Java background, you just don't focus on classes, not entirely, but just see static functions and hash maps, and you're passing them around. Hash maps and functions. These are sets. What is different about set? The way you define the hash map, just prefix the hash. Okay, so internally, just like in Java also, sets are nothing but hash map internally with no values. Same is the case in Clojure. So 1, 2, 3. So it came as CBA this time, right? Every time CBA. 1, 3, 2. Oh, it's consistent. Anyway. Clojure set has its own higher order functions, like from set theory, what are the intersections, unions. There are various many functions. Like if you want to do intersection of this, what would be the intersection of this? 3, 2. Whatever. Okay, union. Okay. So all of these so just like in Java, everything descends by collection interface, right? Everything here it descends from sequences. So if you want to simply build a simple sequence, this is the way. It's a simple sequence. Okay, this is a simple sequence, but when I'm passing to a REPL, it is realized into a list. Okay, and so if you can do cons to a vector, to a list, it's a simple stuff. Any question here? Destructuring. So this is for your eyes only. Okay, so what does it print? So have a look at it. So it's a block, let define ABC. So previously we were just defining the direct values. Okay, let, simple let, example value, key and the variable name and the value, right? Now here you can look inside the structure of the value. So here the structure of the value is list. Here it is a vector. Here it is map, hash map. So you can look into that. Should be able to relate it with ES6 destructuring. So first 67 line, what it shows, point A as in variable to the value as in keyword A, B to keyword B, and C to nothing. Okay? Nil, yes. P to 10, Q to, imagine how much code would you write in Java to achieve this? Here destructuring is about looking up the keys. I am looking for the key, a keyword X, and storing its value in X. I'm looking for a keyword value Y, storing it in Y. Because at my right hand side is 60 and 70 for X and Y keywords respectively. This is understood. We'll jump into more complex one then. Destructuring, we'll see destructuring. Are you able to recognize the pattern? This is peeping into the structure and getting that value.
Dot class files are more readable than this.
Dot
Dot class files of Java.
dot class files.
Of Java bytecode is more better readable than this.
Dot class files are more readable than this. How that can be?
Java code is more readable. You
Java
want
code
to
is
say?
always more readable.
भावना first detail.
So first time you will be bold by only brackets and brackets of Lisp, but once you get used to of it, it's very concise syntax. Not even so ES6 has it, I think C# also has it to some extent. Are you able to understand this?
No.
No.
So what is this value? It's a list of keyword A and B. So if I, right? So when I say A, B, C at the left hand side, what I'm doing is I'm saying def A, def space A space keyword A. Assigning, this is a
मतलब वेरिएबल को एक वेरिएबल को आप कांस्टेंट असाइन कर रहे हो.
this is assignment. Yeah, destructuring is assignment. But this is destructuring by peeping into the list code or vector code.
Okay.
So instead of following multiple steps,
Then PQ go
so P would be,
10.
Q would be,
20.
that's what. Okay, so we understood. X would be,
X constant X. तो उसको क्या असाइन हुआ?
what would be the value of it? Look at the left side and the right hand side. Right hand side is the actual value.
But when did we assign the right hand side value? So colon X.
Yes, but yes. So by saying that the keywords colon X. Yes.
Yeah, but when did we assign that code? Okay.
By writing this,
Okay,
yeah.
okay. And ठीक है. उसके नीचे क्या कर रहा है?
So what will be the value of X then?
But we are assigning the value later, na?
Later in the sense?
At the end of this line, the value of x is going to be 16, y is equal to 16.
Yes. X will be 60, Y is equal to 70.
But वो assign बाद में हुआ ना?
This is the assignment statement. This is the
Okay, एक statement.
destructuring assignment statement. Yes.
Okay. Used to name.
उनको comma semicolon सब जानते हैं.
Yeah, so comma space can act as a separator instead of just comma.
ठीक है.
You can also do that if you want. It won't mind. But it's not needed. Okay, so एक मिनट में I'll just print it out. What is the value, and you try to tell me. Are you able to understand this? The first, so it starts from the value of A is
Colon.
keyword A,
Keyword A.
keyword B, Y nil, because there is no third in the list, so it's nil. What is the value of P?
10, Q20.
20 is the value of
Q.
60,
X को assign
Y. Okay, so sometimes it might happen that you want to assign some default values. Okay, so this is what a map. Key is keyword M and N. The values are Mumbai and New York. And this is the assignment left hand side. So what I'm saying is extract all the keys, which is like L and M, right? And if L is not present, the default value would be London.
So if we add,
Don't try to look at it and grasp like you would master it the way you look at it. Just trying to understand what it is doing.
So if in the last thing, Mumbai, New York, if we add L as Lahore, it will print Lahore, right?
Yes,
Hmm.
let's try that.
Okay.
Okay. Okay, and I'm getting all of these things. Okay, so the last one. So last one is right hand side is a vector 100 to 500 with a step of 100. And what I'm saying, so we have seen the identical thing, like, this is named structuring. Sorry, this is index structuring, this is name structuring. When you do in a map, is a key named structuring, this is indexed destructuring, right? So if you want to define indexes explicitly, this is how you do it. So this is the first, which points at the 0th value and the third value. Zero, 1, 2, 3. So that would be 400. This is the index.
Index assigned.
So this is not the actual keywords you're looking for. This is the index you're looking for. So it's treating, so if on the right hand side, if it's a map, the keys become this identifier,
Hmm.
hyphen this keyword X. But if it is a vector or a list, it becomes the index. Okay, so by default it supports the immutable variables, but there is also provision for something called as transients. Transients are mutable variables and they should be used within the function. So inside a pure function, if you mutate something which you have created by not passing to anything but only using for a local computation,
Hmm.
function still remains the pure. Okay, like घर की बात है.
चलता है.
So so this is the okay. These are two versions of it. One uses the normal default um, persistent vector. The other uses the transient vector. This is the way to achieve it. So you define it and you convert into a transient is immutable, immutated. So what is the V range? It's vector range. So vector range function which is creating. So same thing, loop, recur. Okay, so as I said, it does not cause the stack overflow exception. So let's define it. Define vrange and vrange2. Okay, so if you use, so time is a function for getting what? Like how much time is being spent. How much time? Near about 170, 180 milliseconds. This is for the persistent. The other is transient. So this is like 1 million rounds. 1 million rounds for normal is 178 milliseconds, and this is 767 milliseconds. So it's fairly fast.
तो दोनों में तो वही यूज किया ना, लूप और रिकर ही यूज किया ना दोनों फंक्शंस में.
But yes, but the actual vector in which I am appending, conj is append. Conj is a function which appends the new value to it. So what range function is doing is it's starting with a simple vector, right? And then adding it as it recur over it.
Okay.
Yeah? So 1 million in 67 milliseconds or 180 milliseconds is fine. Yeah? What is, do you think it is less or more?
It is good. Yes. मैं क्या कमेंट करूँ उस पे? मेरा जावा है.
Okay. So you can also define it as this, like transient. So suppose you have a structure here, hash map. How to add a new value? ASOC is associate. Same way. Okay.
So exclamation is again a guideline.
Exclamation is a guideline, and exclamation says that this is a mutating operation. This is a side effect. This is functional programming, right? So
Exclamation mark.
yes, that's a, so if you see exclamation everywhere, your code is shit.
Okay.
Okay. Yet transient doesn't show the value, but this is the ASOCing it. Okay. Any questions until now? Just jump to this is fairly simple. Functions. Functions. Now, for example, we were defining the very dynamic definition of the function. But sometimes it matters that you also define some type hints. So I am accepting long, long, long. So that is how you define it. You have a hat topi character, okay, which you put just before that value. So Clojure is a compiled language. This whole thing is get compiled into the directly the bytecode. It doesn't compile into Java and then Java is no. It directly compile into bytecode.
There is no class file.
Yes, directly into class file from CLJ file to directly the class file. Not directly compile into Java first and then that's not the compilation path. Okay. So
it's just a hint, or it will give error when you pass something other than long.
no. It's just a hint for a compiler. It's not a runtime anything. Okay, we will see that. So so this is the function and this is the var args. If a function has a very many number of arguments, say ampersand, and the C would be
List.
yeah. You can have with different arity. Okay, so suppose if add is getting called with no argument, return 0. Yeah, if it is getting with 1, just return that. And the normal definition. Okay, in Haskell, this is pattern matching, but this is how you achieve it with the arities. Okay, so what would be the add? 0, 10, 10. Okay, now functions also have also support something called as contract-based programming. What is contract-based programming? So whenever you accept an argument, you validate the argument, and whenever you pass the return value, you also validate that return value. That is pre and post. So if subtract is a function, just accept the positive values for it, for this function, for the sake of this function. So positive A and positive B. So this is the list of, this is what? A list of functions. So I'm saying, so this should be all list of trues.
तब जाके मैं आगे.
Yes, and post function, this should be list of all trues. So what I'm saying, subtract takes only the positive values, right? So let's try this out. Define the function. It raises the error. Why? Assertion failed because A is positive. Okay,
दोनों
so
positive चाहिए.
so what if I say only this is not positive, positive B failed, yeah? Only A is positive, then also fail. Okay, so each and every time it's like AOP, like aspect oriented programming, right? It's very parallel to this. So in Java you have the display and transaction internally. um, Most of the libraries um, changes your bytecode, right? Start the transaction, these transactions and all, or do some validations over it. Or if you are accepting some of the arguments or the Java bean values, do they follow certain contracts? Okay, so if I say 3, 2, so what is this function doing? This is the function. What is it doing? This is the function. We are not, see, we are not writing here. There is no need to write a function here. Okay. It is given that it is a function. So internally it will convert into the function. So there is no right. So, so whatever, after subtracting it, whatever is the value, that should be less than max of A and B. If you're doing subtract, right?
That is always true.
That is always true. I'm not saying that this function would be helpful. I'm just telling you how the pre and post are done. You can call anything here. Okay, this is contract based programming. There is a whole language, Eiffel. Eiffel is the language. Eiffel is in like Eiffel Tower. 3, 2. Okay. Okay, so this is done. Any questions in this? Nope. Okay, we have seen contract-based programming. Now, since Clojure is a dynamic language, it tend to get to use some Java reflection under the hood. Okay, if it doesn't find, so for example, what is the length of this? Okay, I defined a function, and if I timed it out, it takes about 6 or 7 seconds. Those are again 1 million rounds. Oh, 8 seconds. Almost 9 seconds. Why? Because it is using reflection. But if you do a type hint here, it's a string. Okay, and redefine that function and now test it with the same input from almost 9 to almost half.
क्या क्या किया आपने मतलब वो 46 लाइन पे क्या किया आपने?
So I have just given the type hint.
Compiler को
क्या कौन सा
compiler
type
clear
लगा?
किया.
Yes. So because it does not uses that it does not compile into Java and then this, it directly compiles into have, and it's a dynamic language. It doesn't assume that. I'm saying just look at the property length of this thing, right? But here I'm saying this. So 1 million operations in this. Okay, so if you want to, so in a big project, if you want to find out that you are using a reflection, just set this flag true. I'm not setting it right now, but if you warn on reflection, it's a dynamic variable. So the whole project, whenever it runs, it will show you the warnings that you are using a reflection. So wherever you are using a reflection, you provide a type hint. And Clojure will run as fast as Java, even if it's a dynamic and kind of um, higher level language. Okay. Second, so this is another example for this. So sometimes type hint, you can also convert them. So look at this example, foo and foo2. They are the same, but only thing here is I'm explicitly converting into an int. Okay. So that will also have, so one time. So how many seconds? 33 milliseconds. Okay, I'm just putting, if I define this to, and 3 milliseconds. For 1 million operations, I'm just, okay. So that is how function and type hints works. Okay. As far as it goes with the interop of the Java, okay, it provides sufficient methods. Like for example, how would you, so in Java you write some string dot uppercase. So this is how it is written here. Dot to uppercase, and then, so function always comes first and then the object and then arguments. Okay, so get name. So let's evaluate this. So it will return uppercase, it's a name of that string that is in class, right? So Java AWT point. So these are similar. How do you have a new? Because Java has classes, right? Clojure is built upon JVM, but it should have a interoperability with the many of the Java libraries, right? Because if you are not able to make use of them, because Java has many open source libraries which Clojure can make use of. Not everything has to be rewritten in Clojure. Unless you demand the very your requirement is about building that specific DSL way, very dynamic behavior if you want. Okay, so what it does, it's new Java IWT point, constructor accepts value 1 and 2, and get X, get Y. Okay, so that is written in a single line like this. 1, 2. System dot get property. What is the Java VM version? Okay, or this is what? A static method, system dot get property. Static function in that class, system class. This is static function in math class. Yeah. Clojure has some macros, threading macros and dot macros. So instead of saying system dot get property and this thing, I'm saying that on system call get properties, whatever it returns, call get OS name, and just mention it here, dot dot, but only focus on the flow you will get. So this Mac OS X. Yeah. Similarly, this is a threading macro, system.get properties, and on that thing you call the get. Yeah, I can also say here, like for example, to uppercase. Yeah, because it has to have interop with Java, and Java results into many ceremonies. It has some other macros, like for example, hash map, new util hash map. Then you define a variable, then to put and all. So I'm saying do to this, do to the first thing, and do rest of the thing actual operation. Do to this guy, the object of hash map, these following operations. Okay, so this, okay. So how do you, any problem here? So you're able to identify how it's going, right? The second, now how do you have Clojure to Java and Java to Clojure when it comes to data structures? Because Clojure not only have their um sequenceable interfaces, persistent list vector, but they also extend Java's util collections. Okay, so bringing the new language to the platform does not mean you have to break its certain contracts, and data structures are very at the heart of any other languages, right? In which are mentioned in the standard library. So everywhere is a list and array list, hash map in Java and other open source libraries. So this is how you achieve it. So how I'm saying it, Java util list, or instead of dot, we can just say new array list, that is 1 2 3. So here what I'm passing, a vector, but if, but what I'm calling the Java array list SDK. So Java doesn't know about Clojure. Clojure knows about Java, right? Clojure sits at the top of Java, but Java doesn't have any idea. We are able to achieve it because the vector itself, it's the collection. It extends the collection internally, extends the interface. Okay. And if you want to get like index, these are the things. Same is the case with hash map. Now hash map here is, we are not passing keywords, we are passing strings, because Java doesn't understand keywords. Java understands strings. Yeah, and how is it Java to Clojure? So you have a library, you take into, you get that library, sorry, yeah, and the method, you call that method which returns an array list. But if you want to use some higher order functions, what you do? You convert it into hash maps, sets, Clojure things, so that you get access to more values. Okay, so all of the things which have seen map, filter, and all, it provides interoperability, but it does not provide the whole thing, Clojure, right? So all of these things, sequenceable, so many functions are in a different interface, which Java or ArrayList doesn't implement. So it has to be converted into the Clojure. So this is how you define, convert ArrayList into vector, hash set into Clojure set, linked list into
List.
Clojure list, hash map into Clojure hash map. Okay, so 1 2 3. This was U1. Yeah. Okay, so no problem. Let's wrap it up in next 10-15 minutes. So we have macros. We have seen many things, right? So Clojure is a homo-iconic language. Code is data is code. Okay, so there are something when it comes to reusability of the code and removing the boilerplate code which you have to uh, you know, kind of extract from your language, from your code. there are various ways of defining it. Like for example, map filter function defines the higher order function. It's to certain extent it do away with the for loop and all these things, but there are certain things which requires more kind of rigorous things to be happen. Okay, so for that we use macros. So macros are nothing but when you define it. Do you remember the basic macros which you return C++, like add? So the whole code where you write this macro is transformed into some other code during the compilation, and that code again get compiled.
It's just replacement. Like.
Yeah, replacement. Okay. So what if I want to write, you don't like the in the Clojure way of doing it or Lisp way of doing, like function comes first. You want to go back to the infix thing, 1+1. So this is how you write a macro. So I'm writing a macro, but don't do it. I'm just saying it. You can do it. It just doesn't mean that you have to do it. So infixed. So what is infixed? So when you define a macro, all of the things which comes after it is taken as a list, because code is data is code. Okay. So what is the first here? So how would you convert this? 1+1 plus 1 1, right? In Clojure. So get the second, put it on the first, get the first, put it on the second, and the last on the last. Okay, so if you, okay, so let me, huh?
हमने बोला ना don't do it करेंगे. You put.
So this is when macro, which is inbuilt. So what it does, so I'm not defining here expression. I'm just doing it. So and again I am prefixing it with a quote. Yeah, and there is a macro expand. So what macro expand does is it expands the macro to see it how it looks like. You don't have to wait until the whole compilation happens and you have to put console.log or system out.println. Is it what I'm expecting or not? You just have to do, you can just do it. Like if I were to expand it, it will expand into if. Okay. You able to understand this, eh? Okay, so what if I call infix 2, but what is expanded into +1 1? Okay, I have given you very hello world of macro because I care about you. Yeah. There are very different. You go into def macro or defen. There are many other macros. Okay, so last stage is how to build an abstraction. This is okay. So we have until we have seen data types, functions, Java interoperability, and all these things. But when you build an abstraction, you have to have something like you can't depend only upon functions and namespaces and all these things. You have to have some other abstractions like concrete records, types, and interfaces. What are interfaces in Java or any other language? They are 100% abstraction contracts which need to be filled by something else. So when two party kind of communicate to each other, do they implement the same method with the same semantics, return types and all? Okay, so we have def record. So def record are the record types. Okay, or maybe wanna cover type first. Anyway, so def record is a person. So what I'm saying is internally it is a hash map only, Clojure hash map only, but it is also a certain kind of a type. a record, okay, which is a type is core abstraction person. Same is the case with address, and this is how I define the instance of it. Julia is the person, and here I'm not maintaining any type. You can maintain type hints if you want. Okay, so that's how. So Julia is what? A person, Julia Roberts, with the address of this. So what is the type of Julia? Person. Core abstraction, which is the namespace name and the person. What is the type of person?
Abstraction.
Java Lang class. It's a class. What is the last name of Julia?
Roberts.
What is the last name as a property? So this is two things. So def record supports both. Def type and def record supports both. Like look as if it's a Java class by dot last name as a property or as a hash map. Okay. The so if you want to go into something, the nested hash map, then Julia address city. So what is New York? So it inside a person, inside an address, and then city.
Dot dot is for functions, Java functions, right?
You are creating a new instance of a record.
Any the arrow and dot dot.
The arrow.
14, line number 14. Arrow is going deep inside the record, right?
Yes.
And the dot dot was for Java. Dot dot.
There was it's not about Java, but Java-like things. Yes, I mean the property-like things. So Ashok, Julia, first name Jennifer. Associate. So these are immutable. Even if you def record, it's implement a Clojure hash map and some sugar layer over it, which makes it looks like a Java bean, but it's immutable. Okay, so if I say Julia, provide new property of first name, so it will return new thing. It will keep that thing as constant, but it will return new thing. Now it's a Jennifer Roberts. If you look at the record, the first name has been changed. Okay, you because it's a hash map, uh, it can take other attributes which are not mentioned here. So why to mention then? Why can't we use just a simple hash map? This is like a domain objects. Have you heard of structured types? So most of the languages like Java uses like it. Say for an example, two classes A and B have the same properties, several properties, right? In a given method where you are doing certain computation, you are only care about those properties. You don't care about the type. If those type have the property, if that object has the property, it's fine. Okay, so it only is interested in the structure of that object, is not interested in the type, named type of that object. It may have other fields. I am not interested in that. That function is not interested in those, but it is interested whether it has those many properties or not. These are called structure types. Like for example, Golang has the structured types. It only looks at what is the structure of that object. Okay. So def record are mostly used for domain modeling. Okay. So this is my domain. It might have certain attributes, but what I'm only interested in, does it have these attributes with this type hints and all which I'm expecting? It might or might not have other attributes, I don't care, but does it have the follow structures? Update in. So we have so again we have seen only changing the first level, first name, but what if it's a two level inside the address if you want to change the zip code? So there is for update in. So it goes inside address, look at the address first and then take it to zip. And this is the function you provide, which returns the old zip and you return the new zip. Okay, so it returns the new object of person. It doesn't update in the actual this object which we have created. Same is the, so whenever you define def record, it also generates some helper functions like these ones. Arrow person, arrow address. And it does the same thing. It's like a factory functions. Okay. Christina. Okay, we'll jump to def protocol, but this is okay. Def record. Simple hash map is not restrictive as Java class. It's like between. It follows structure wise, but it doesn't restrict to be get expanded. Okay, def protocol is like creating the interfaces in Java. What interfaces? Just pure abstraction. Tell me the name of the interface, what are the different methods, the signature of the methods, and that's it. Yeah, so I am defining where creature, full moon behavior. So this is the method, this is the protocol, this is the method. It accepts a argument. I'm not saying what kind of argument. Even if I give type hints, it will be only useful for compilation, but I'm not restricting it to be of that type. For that, I have to do pre and post contract based programming if you want to do it. But it is discouraged in dynamic language programming. So def record. So again, I'm defining a def record, but this time I am defining the name, the properties, and also implementing the protocol. It follows some protocol. Again, everything is list. I'm just mentioning it. This is the protocol. I implement this behavior this way, which returns this. So let's evaluate it. Okay. Werewolf. Yeah. So if I, what is the example here? Where maybe example we can see. So if I have werewolf, what is the name?
See,
Huh? So this is the object I have created, and I want to what he does, the Dracula on full moon behavior. Okay, Dracula will haul and murder. Okay. Oops. So same way you can have multiple file foo, bar me. Okay, so this is a protocol which has two methods, foo and bar me. um, X, XY, and there are two versions of barme. It should override two versions. First, which takes one value, one argument, and second argument. And I'm implementing for now for def type. Now type is a very restricted Java class like thing. It doesn't implement hash map. It doesn't even implement identity equals hash code and all. It's simple, dead simple. Okay, so this why def record and def type. Def record is only if you're having if you want to do domain modeling and still you are in the Java sorry in the Clojure world. But if you want to interact with Java world, foo and all, sometimes it doesn't matter like equals and hash code, and it doesn't have to be a hash map. It has to be only and only the property access, but from inside the that particular class. For example, in Java, if you have property, you can private property and all kind of property. It is only mutated or accessed from within, right? And you only access that with uh, from outside from getter and setters. Yeah. So this is the kind of scenario where you would take this. Most probably don't use def type unless it is really needed. Okay, so but it is more strict version of it. Okay, so let's define P. Oh, I've defined it. Let's define a foo which implements the so foo it returns the first A, barme returns the B, and second value returns the C plus Y. Okay. So these are like ABC are like this value which you take from constructor. This is the value you take from the method argument when you actually call it. So what is barme? 42. How? The last value 3 plus 42 C plus Y, right? 3 and 42 is 45. You are calling a barme function because function always comes first in list to an object which you have created here right now. Passed 1, 2, 3. So 3 points to C, C plus Y, and Y is the last argument Y. 2 is so 42 plus 3 is 5.
What is the first argument? The object itself.
The first argument is the object itself, yes.
Okay, so what if I wanted to call the second barme function? Then just 42.
Second,
The
so
single argument barme.
single argument
42 number line, that function if I wanted to call, then
40, which one?
the function on bar for line number 42, right? The single argument barme. You have two barmes, right? Single argument and double argument.
Yes.
So if I wanted to call the single argument barme function, then how should we write that?
Okay, this one.
Uh,
45. So in this case, def type, the func, this is this. He always is this.
so it should return 42.
Let me.
So protocol is not violated.
For def type, yeah.
In protocol we have single argument binary, right?
Mm-hmm.
But we don't have that in
Yeah, but in def type it acts as a this value of this.
Mhm.
This value is always like in Python you have self. The first argument is always self
Mhm.
in Python, right?
Mhm.
When you define, so that is like this.
In Java.
There's nothing to understand it the way it is. The first argument is always the object you are passing. ASOC. This will result into exception, unlike in def record. It's not extendable. Then there is refi. What refi does, sometimes in Java also you return an iterator by implementing the whole interface, right? By implementing the whole interface, suppose you have an interface. You, you do not write always the class implements it in a different class file. Basically the anonymous interface, anonymous class. So this is how you do it in refi. So I'm saying foo refi. Okay. So what would be the result of this? You are calling foo on what? This object. So instead of saying def record and implementing that object, you're just simply having it here. Refi. Just implement that protocol. But it is not attached to any def record or def type. This is the last one. So suppose you have a def protocol, I read name, get name, set name. The first thing is always act as a this. Okay. Then a type person name. Now you are saying that it's a volatile, mutable. It can be also mutated. So this is how you mutate it. Like for example, in Java you get and set name. This is how you actually would write it. But don't write it because Clojure. But if you want to write it for some reason to interop with Java or for some performance reasons, performance reasons would be hardly any. But if you want to write it this way. So set, again the exclamation mark, it's a side effect. And this L name, so this is a special instructions. Remember we have given special instruction by being a dynamic, where is it? The dynamic. This is a special instruction. This is a meta instructions. Okay, so this is a special instruction which I'm giving. Yeah. So if I define this, this would be, you define, you set the name and then you get the name which will be different from what set. Okay. So because in Java, it follows OOP pattern, right? So data and the functions are bundled together. They are not separate. Here you have a def type, def record separate so that they can extend the way they want, and the protocol is different. It can extend the it wants, like implementing or incorporating other protocols and other types. But in Clojure, you can extend the inbuilt types. So suppose the string final class in Java, you cannot have a new method on it, but in Clojure you can have it. Okay, so this is how. So implement define a protocol, extend the Java util date by adding a new method which is called as 2 milliseconds, and implement it by saying extend. Extend again is the keyword. So it extend the whole thing, and then you are be able to have. Okay, so the record is different, the protocol is different. Any record can have, it doesn't matter that what is already implemented in standard library, you can go on implementing more protocols so that it provides more methods, right? This is to avoid expression problem. And the last thing for this abstraction thing is multi-methods. So polymorphism. So sometimes polymorphism is based upon the type. So suppose there is a person, and sorry, there is a human being, a parent class, and a person as being the child class. So parent-child relationship. So depending upon the object, what method you call and override will get called at that dynamic runtime, right? If you have overridden it, right? But what if you want just simple dynamic polymorphism? So it may not be on any def record def type, but just it defined at the runtime. So that is how you do it. So you define, this is called as multi methods. This is def multi, and these are various versions of it. And the way you do it is, so for example, it's a static thinking. When you do like def record and def type, the object is known already in the code. But what if you are passing here any object which has this attribute where type? I don't care if it has very many other attributes, or it's a type, a def record type or not. So def record is like type also and hash map also. So this kind of polymorphism is only for simple hash maps or vectors or any other raw data. It's a raw achieving polymorphism over the raw data. So this full moon behavior, I could have implemented by saying Wolf and Siemens as a two different record and overriding them by implementing some protocol. I don't want to do that because those are not domain models. Those are simply the strings. So I define it. So whenever I call a full moon behavior with this, what it does is it in it pass that object to this function, get the return type, and if it is Wolf, then this method will be called. If it is Siemens, then this method will be called. Yeah? So tell me, how is it different than cond? Cond is a similar thing, right? So this function, cond, sorry, cond p, suppose cond p, not this one, cond p. Cond p, this is the function you are writing it. This is the one. So this is what?
सिंबल यूज करते हो वहाँ पे
What symbol?
एब्स्ट्रैक्शन मल्टी मेथड
This is just a polished way of doing it. A cont b, okay, where you have multiple
एल्स नहीं है इसमें
things,
कंडीशन
and then you call it simply full moon behavior. What is got called? Oh, sorry. Rushing from the next door, and if it is Siemens, then it will encourage the people and spread to all boys. Okay, so this example which we left, now you'll be able to understand this is what vector, this is set. Okay, and this is what, these are just the functions. So some function is called with this as a first argument, set, and this as a second argument. If it returns true, then increment will be called, otherwise decrement will be called. So let's 3. How it came 3?
सम नाम का फंक्शन है क्या है
Hmm.
किधर है
Sum is the function. Sum is the sum like odd. Okay. So range of 5. True. Some of them in that range are odd
हाँ
or any.
सम इन दैट रेंज और
Some in this range, in this sequence, follow this predicate, satisfies this predicate. It's
So,
like ORing,
some-
ORing.
सम के बाद प्रेडिकेट आना चाहिए बेसिकली राइट
It's a higher order function.
सो जो कॉन पी वाला है उसमें प्रेडिकेट क्या है ये जो नीचे लिखे है
What is the predicate?
Predicate मतलब
136 में और प्रेडिकेट था सम ऑफ देम सेटिस्फाइज द व्हाटएवर वैल्यू देयर इज राइट
hmm.
तो आई वांट
So let's say 0, 6, 7 and 1, 2, 3, 4. Right? So you try this thing. Some of these are present, right? It's not present. Is 4, 5, 6, 9 present?
ओके
Is 1, 2, 3 present? Then decrement. So it will so it will return 4 here, right? So 4 you decremented, from which you get 3.
the decrement and increment is working on what
The output of the value.
what is the initialization of that value
4 is the value, right? When you applied this, it won't go until this last thing. It will short circuit here. It returns a 4. 4 is a truthy value. What are the false values? Nil and false. Rest all of them are true values. So true. So whatever comes true, just invoke this function with that value, decrement 4. So it returns 3.
okay, so basically 139 condition fails it comes to 140 144 is the intersection or whatever and that whatever is returned that it decrements 4 so the value is 3 and it doesn't go to 141 and returns 3
Yes. So these guys who actually written the language, they are fiddling with functions very often. So it's very clear that they came up with some certain abstraction which are more common when you kind of do such kind of thing. Don't go into how syntax looks like, just as I said, get the usability, what you're trying to achieve. Now try to compare with Java or any other language for that matters.
Java is a straightforward comparison because both are JVM languages. Or it can be compared with
It doesn't
Scala.
have to be JVM languages. You can compare with JavaScript also. Yeah, but for you, I mean, whoever, whatever is your primary language, you can compare with it and see how much you are able to achieve this. So the higher languages let you think first. Imperative languages, the way you think, they let you type it the whole shit.
Yeah.
Higher level languages says no. If you first think, go have a coffee, and then only write that declarative code, just like this quantity.
Okay, so what is the paradigm of this language?
As we have seen, like it supports functional, of course.
It is a
It's
functional programming language.
it's a Lisp. It's basically so other than for being functional, any other paradigm, it supports what? It's a lambda. It's a lambda calculus. It supports functional language, functional paradigms. The whole we have seen. It supports imperative by which you have seen in the do blocks,
Yeah.
one by one statement. It also supports object polymorphism, right? Which we have seen. It also supports direct polymorphism using multi-methods. So Lisp is not the language where you say that what kind of program or what kind of
Programming paradigm.
paradigm it follows. It also embeds another languages which I haven't covered. So when you implement, like for example, HTML templates and all, so other languages are embedded into the Lisp using finer, those four data structure which I mentioned: list, vector. A vector is just like the offshoot of list, but list, hash maps, and set. List and hash map sets like
Why should I use this over Java is because the number of lines would reduce.
you are only focusing on the behavior. You are getting more stuff done, right? Have you seen such a things in Java in build? I haven't used any library here.
Right. Yet so many,
Yeah.
so few lines of code.
I haven't used any library. If you look at library, they are very beautiful. I mean, the core.match, core.async, core.logic. So it also follows the logical paradigm. Okay. Okay.